So if you know the opposite and hypotenuse, you can use the sine -1. If you know the adjacent hypotenuse, you're going to use cosine -1. And if you know the opposite and adjacent, you can use tangent -1. Where are these located on the calculator? If you look on your calculator and you see these buttons, sine, cosine, and tangent, you should see a button above it, sine -1, cosine -1, and tangent -1. These buttons are used when angle is known. These buttons are used when looking for the angle. So if you know the angle, use the sine, cosine, and tangent. When you're looking for the angle, you can use sine -1, cosine -1, tangent -1. Also, one other thing, that sine -1 is not the same thing as 1 over the sine. Okay, they're not the same thing. Given the right triangle with the sides length 5 and 12, find the measures of the acute angles of this triangle. So again, with respect to angle A, the 12 is going to be the opposite. The 5 is going to be the adjacent. So what trig function uses the sides opposite and adjacent? Tangent does. So I'm going to go ahead and clarify what the notes has. So the tangent of angle A is equal to opposite over adjacent. Plug in what you know. And since I'm looking for the angle, I'm going to take the tan -1 of both sides. Whatever you do to one side, you have to do the other. Tan -1 and tangent should cancel out. And this is where they get the formula right here. Make sure you put the fraction inside of parentheses, or make sure you find out the value of 12 over 5 before you do the tan -1. And you should get what they got of 67.4 degrees. Now in terms of angle B, what did they do? They subtracted 90 minus angle A to get 22.6. But we can do the same thing as we did before. With respect to angle B, the 5 is now your opposite, your 12 is now your adjacent. So the tangent of angle B is opposite over adjacent. Tangent of angle B is 5 over 12. That means that angle B is going to be the tan inverse of 5/12. And you should get 22.6 degrees. I like doing it separately because I like using the definition that if you add angles A and B together, you should get 90. If you don't, that means one of the angles is incorrect. Now for this one, I want you to pause and see what you can do on your own. This one says to find the missing side and 2 missing angles. So in this problem, we're given a right triangle where I do not know angle A or B or side A, but I do know sides B and C. So to find the third side of a right triangle, I'm going to use Pythagorean theorem. If you want to go ahead and get A by itself, I want to go ahead and subtract B squared from both sides. Then take the square root of both sides. So side A is the square root of C squared minus B squared. 30 squared minus 18 squared, you should get 24 feet. Now let's take a look at angle A. With respect to angle A, B is going to be the adjacent. C is going to be the hypotenuse. So what trig function uses the adjacent and hypotenuse? That would be cosine. Cosine of angle A is going to be adjacent over hypotenuse, or B over C. So that means that the cosine of angle A is going to be 18 over 30. Now in order to find out what angle A is, I'm going to take the cosine -1 of the fraction 18 over 30. I'm going to plug it in my calculator like it is. Now in order to get the cosine -1 button, I have to hit the shift or the second button on your calculator. Put the 18/30 inside of parentheses. And I will get the angle rounded to the nearest tenth of a degree, 53.1 degrees. We could, in order to find out angle B, subtract 53.1 from 90. But I'm going to go ahead and do it by using the trig function again. So now I'm going to do with respect to angle B. That means that side B is the opposite now. C is always the hypotenuse. That's going to give me sine of angle B. Sine of angle B is going to be B over C, which is 18/30. So B is equal to the sine -1 of the fraction 18/30. You should get 36.9 degrees. And it's just to double check, if you add angles A and B together, do you get 90 degrees? You do. That means that both angles are correct.